So in the previous two tutorial videos, we discussed how you can solve the two kinds of problems in a general way. So for example, if you are given an array, how you can determine all the numbers are positive, and versus how you can determine if there's at least one element that's positive, right? So we talked about version 1 in the previous two tutorial videos. So now I would like to show you version 2, okay? And now version 2 is going to be very similar to version 1. So that's why, I'm going to do a copy and paste. So just to highlight how similar they are, but they might work differently. Okay. So what I will do is, first of all, for all positive, I'll simply copy. Let's go to the all positive version 1. Okay. So simply right click and say copy. And then we're going to say right click and paste over here. And then, so now, simply all positive version 2. Okay, that's good name. Okay, you can say okay. So now in version 2 over here, okay, we mentioned before in the tutorial video previously, this particular part over here, the purpose of that is to accumulate the result of comparison over here between iterations. That's how we remember and also accumulate the comparison result from iteration to another iteration. Okay. That is why we have to set the initial value to be true in a particular way. If you have doubts about this, please refer to the previous tutorial video. Now, the only change I want to make version 2 is to get rid of this particular part. So which means there may not be any accumulation or remembering anymore. So now the question is this code going to work? If so, why? If it doesn't, why not? Okay, it's a challenge for you. So before you go on with the video, you can pause right now and think about it before you try to play again. Okay? Okay, assuming that you have thought about it, so now let's have a look at why this may or may not work. Let's convince ourselves, first of all. Okay? So now, for this particular array over here, do you think it should return true or false? Well, since we got at least one violation witness, that's going to make sure it is negative. So that means the overall result should be false. Agree? Okay, let's see if that will really return, it will really print out false as expected. If I right click on version number 2 and say run as Java application, it actually tells me that it is actually true. So this is already wrong. Is it always wrong? Well, let me try another input. Let's say I modify the last elements over here. If I modify this to be, let's say, -7. Okay, so what do I expect to see? I expect to see, again, because this is the very first witness for violation, so the overall result should be false. Let's see if it is going to return false. Previously, we know that it's returning true, whereas it should return false. But now, is it going to return true again? So let's find out. Let's right click on all positive version 2 and then run as Java application again. Wow, you see this time here it's returning false as expected. So it seems like after the particular change we made by getting rid of the accumulation part, it seems like sometimes the program works and sometimes it doesn't work. So why is that? Okay, so it's not good because you want your program to always work, not only to work occasionally. That's not something you want. Okay, so now let's try to illustrate exactly what's going on over here. Okay, so now let me move on to iPad. I'm going to illustrate it to exactly what's happening for the two input values that I just run. Okay, let's move on to iPad over here. Okay, so now before I do that, can I just do something very quickly here? Okay, I just want to copy and paste the code for version number 2. Okay, and then I'm gonna only copy the part for array initialization and also the loops over there. Okay, let me paste the code to iPad over here. Okay, that's the new version of code that we are having over here. Okay, so now let's see exactly what's going on here. Okay, so already filling parts of the table, so we don't have to worry about. So first of all, we're convinced it's going to run 5 iterations, right? Given that the state condition over here is just simply standard I strictly less than n is that length. Okay, let's agree on that. Okay, so now I'm going to skip that part for the tracing. So now I'm just going to do exactly 0, 1, 2, 3, 4. Okay, these 5 iterations. Let's see exactly how it's going to work. So now I want to start with the first version of the array where ns is simply 2, 3, minus 1, 4, and minus 7. So what do we expect to see? What is expected? Because we got at least one element over here that's negative, that's a violation witness. So we expect that to be false. So it is not the case that all the numbers are positive. Okay, so now that's what we expect to see. Are we really going to have false from the program? So what's the actual output? Okay, so something we don't know yet. Okay, that's something I'm going to trace. So now let's see exactly. So now the body of the loop is much easier to actually execute because it's simply just all positive, simply reassign to whatever comparison result it is, depending on the loop counter I. So now when we have this, for the very first iteration, ns at position 0 is going to be 2 larger than 0. In that case, it's simply just going to be true. In the second iteration, it's going to be 3 larger than 0. Oh, actually, before I do that. Okay, for the first iteration, we know that the comparison result is simply true. That means all positive, or remember, initial value for that is simply just true. Okay, and then after the first iteration, we're simply going to rewrite it to just true. Okay, what about second iteration? For the second iteration, I is simply 1. So now we're talking about 3 over here. So 3 larger than 0, which is true. So now we're going to reassign this particular true over here to all positive. So simply reassign that to true. No accumulation, right? And then what about third iteration? The third iteration, the value is simply minus 1. So minus 1, so I is equal to 2. Minus 1 larger than 0 is actually false over here. Okay? That means we're going to reassign this false to all positive. If you can just review your notes or the previous video, so far the behavior is the same as the version 1 where we do have the accumulation. But now we want to see if the accumulation can be remembered. Okay, let's go on to see. If we go to the fourth iteration, so now we're going to see at index 3. So now it's actually 4. 4 larger than 0 is going to be true. Okay, so now we're only going to reassign this true over here back to all positive. That means what we're doing over here is reassigning that to be true. Notice what's happening over here. When we actually going from false back to true, that means we are forgetting about the previous accumulation result, which is not the case for version 1. Okay, it's a very critical point for you to remember, to realize. Okay, so now as soon as we get to true, so that means every time we are only reassigning all positive to the current iteration that we are doing the comparison. So what about iteration number 5? Oh, sorry, iteration number 4. Okay, over here. So now we are done with okay, we were just done with it. Sorry, just get a little bit myself confused. So now we're done with the 4 iterations so far. So what about the fifth iteration? So now for the 5th iteration at index 4, so now we got minus 7 larger than 0, which would be false again. And we're going to reassign this particular result being false back to all positive. So now we go from false to true, and then true to false. And that happens to be the last number in the array. So now eventually we're going to say false. So the actual result is actually false, which matches what's being expected. I would say we are lucky, simply because the last element is simply just happen to be a possible witness for violation. So I'm not sure if you already see what the problem is for this particular version 2. Let me just tell you right away. The problem is, if we are having a loop body that looks like this, where we simply don't have any accumulation to remember the previous iteration result, that means the result for this all positive does not depend on the accumulated result for all the iterations over here using conjunction, like what we did in version 1. All it depends on will be just the comparison result for the very last iteration, which is over here. If for the very last iteration is going to give you false, the overall result will just be false. If the last iteration is going to give you true, the overall result will just be true. Let's see another example quickly. Okay, so now I'm going to use another color here. So let's say I'm going to use blue. Okay, so now let's consider this particular array. Are all the numbers positive? So what do we expect to see? Expected in this case, let's see over here. Since we got -1 being the violation witness, so expected should be false. So what about the actual result? Let's say we put a question mark. We don't know yet. Okay, so we're going to trace the same fragment of code again to see exactly what's going on here. Okay, so now we're still going to have, let me just put it aside. We still have the all positive number initially is simply just true. Okay, the same as before. So now we're going to go through all the iterations. Iteration number 1, I is simply 0, so we have at 0 index, we got 2 larger than 0, which is going to give us true. Okay, so now that means we're going to reassign true to all positive. Okay, that's what we do. What about second iteration? For second iteration, we're going to look at index 1. So second iteration is exactly over here. So now that means 3 larger than 0 is also going to give us true. So reassign this particular comparison result back to all positive. So reassign that to true. Okay, so far so good. Okay, what about the third iteration? For the third iteration, I would be 2. So that means we're looking at -1 over here. That is the witness for violation. So now, in that case, we have -1 larger than 0, which we know that is going to give us false. And then we're going to reassign this particular result back to all positive. So we're going to go from true to false. Okay, so far so good. So now we're going to see what's going on here. And now we go to the next iteration where I is simply 3. Index 3, we got 4, which is positive. 4 larger than 0 is simply just true. And so that means we're going to reassign true to all positive, right? So now that means this will become true. So what does that mean? We have just forgotten about the accumulation effects from the previous comparison. So now it's simply just true. Okay, so far we have concluded that the numbers we have seen so far, they are all positive, which is not right, of course, right? So now let's go to the last iteration where I is simply just 4. And in this case, we are not lucky because the last number in the array at index 4 is actually 5. So now we got 5 larger than 0, which is also going to be true. That means we're just going to reassign true back to all positive. So true back to all positive. So this is the final result we get. So that means the actual result is simply just true, which does not match the expected value false, right? You can see that again, for this particular version, version number 2, when we simply got ns at position I larger than 0 as opposed to the accumulated version using conjunction, all it depends on will be the last element of the array. If the last element of the array is going to make the comparison result true, like in this case, the overall result is going to be true, like in this case, right? If the last element of the array is going to make the comparison, let's say false, like in this particular case, the overall result is just going to be false over here. Okay, so now hopefully you can see that. Right. So that's why the version number 2 is simply wrong, by simply getting rid of the conjunction over here, right? That's what we have gotten rid of. So now I really want you to understand why version number 2 is false, and also when can it return the right result, and by luck, and when can it return the wrong result, simply because the last element over here is simply just tell you it's positive, but that's not right because you're not remembering anything. Okay, so that's about version 2 for all positive. I'm going to do something very quick for all positive for the some positive. Okay, so now what I will do is this is wrong version. So now I can put it down and say this is wrong without the accumulation. Okay, that's something we can say. So now let's do version number 2 for some positive. So now right click on the Java class some positive version 1, and then we'll say copy, and then right click again, and you will say paste. Okay, and then I'll simply say, yep, some positive version 2. I'll say okay. So now let me double click on that. Similarly, I'm just going to get rid of this part over here for the accumulation or remembering. And as we can somehow predict, because the two versions work in a symmetric way. So now I can say this is the wrong version. Okay, you can say wrong version without accumulation. Okay, let's see exactly why this is wrong. It's really important for you to see. Now, as an exercise, can you pause right now for the video and then think about why this version will be wrong? You can try to use the tabular tracing I did for version number 2 for the other problem over there, and to see why it is wrong before you try to continue with the video, which is what I'm gonna do. Okay. So now wrong version. Why is that wrong? So what I will do is I'm gonna copy the code again. Okay. Initializing. Oh, let's first of all, let's try to see some output over here and see why it is wrong. Sometimes it is wrong, and sometimes it is not wrong. Okay. So now, what about for this particular one? Well, pretty much the same idea, because there's no accumulation over here. So the truthfulness for the sum positive eventually only depends on the very last element in the array, and see if the very last element of the array is positive or not. In this case, the last element over here is simply -1. So it's simply just going to give you false. And this is the wrong result, because we can see there's at least one element, which is 4, that is positive. Okay, so for this particular array, we expect to see true. However, it's going to return false, simply because the last element here is not positive. Let's double check with that. Okay, right click on version 2, and then say run as Java application. Okay, you can see that's returning false, which is not right. On the other hand, if I modify this last element over here to be, for example, 9 over here, which is positive. Again, basically every element in the array before the last elements doesn't really matter, because the way we wrote the program, only the last element, only the last iteration matters. Okay? In that case, what do we expect to see? Well, we expect to see true, because 4 is simply a witness for satisfaction. However, the program is simply just going to give you true by accident, by coincidence, simply because the last element in the array is simply positive. Okay? So now if I right click on this and say run as Java application, it's going to give me true as expected. But sometimes it's going to give you true as expected, but sometimes it's going to give you false as not really expected, right? So the program is not exactly working. Sometimes it works, sometimes it doesn't work. Okay, let me just now try to do the same analysis again to show you why this is wrong. Let's do it quickly. Okay, so now let me again try to copy this fragment of code over here, and then I'm going to paste it to iPad over here. Okay, so now let's try this. And then again, I have already filled in the table for all the iterations, assuming that you're convinced that we're going to run 5 iterations for the array of size 5. Okay, let's do this particular tracing. We'll do 2 again. Okay, let's say the first one, let me do pink. Okay, so now ns is simply, let's say we talk about this particular array first. Okay, you can see the last element over here is simply 9, so we can expect to see true. Okay, let's again talk about what's being expected and what's the actual output. So what did we expect to see? Because now we want to see if this is some positive number. Indeed we do. So this is the at least one of the positive number that can be the witness. So expected would be true. What about the actual output from your program? Let me put a question mark. Let's find out. Okay, initially it's simply just false, right? Some positive initially is simply just false. And now what about the first iteration? For the first iteration, we simply get I being 0. So ns at position I, ns at position 0 is simply going to be -2 larger than 0, which is going to give me false, right? So that means we're going to reassign this false into some positive, right? So that means reassign that to false. That's okay. And then what about second iteration? Second iteration, index 1, stores -7. So -7 larger than 0 is going to give you false. Okay, so that means you're going to reassign this false into some positive. So reassign that to false. Okay, what about third iteration? For the third iteration, it's going to be index 2 for I. So now index 2 stores number 4. So 4 larger than 0 is going to be true. So now we're going to reassign true to some positive, right? So now it's going to be reassigned to true. So far, so good. Okay. So now let's see how we might forget about the accumulated result. Okay, we'll see that. Actually, in this case, we wouldn't forget because let's see, in the fourth iteration, where I is simply 3. So now at index 3, we store 5 over here, right? 5 larger than 0 is just going to be true. So we're going to reassign true to some positive, right? It's just going to be true. Okay, so far so good. And then what about the last iteration over here where I is simply 4 and we have 9 over here. So 9 larger than 0 is going to be true, and then we're going to reassign true to some positive, right? So now we're going to say also true to true. So this is the actual output we have, which matches the expected output. So that's okay. But now let's see the case where it doesn't work. What if we are unlucky? Unlucky in the sense that we expect true, but somehow the last element in the array is not going to make it true. Okay, let's see exactly how. So what I'll change the color. Let's do orange. Okay, so now to orange, let me just redraw this particular important variable, some positive. Okay, I'll put some positive over here, which is initially false, right? I'll put false over here. And then let me just modify the array. Rather than 9, it's going to be -1. So we talk about this ns over here. Okay, let's trace it again. For the very first iteration, it's going to be looking at I being 0. So at 0 index, it stores -2. So we got -2 larger than 0, which is going to give us false, which means we're going to reassign false to some positive. So this is okay. Okay, what about second iteration? At the second iteration, I would be 1. So at position 1, we got -7. So -7 larger than 0 is going to give us false. So we're going to reassign false to some positive. So now it's going to be reassigned to false. So far, so good. And then what about third iteration? I is going to be 2. So now at position 2, we actually got 4. So 4 larger than 0 is going to be true. So this is the case where we reassign. And then false is we're going to reassign true to some positive. So which means it's going to be true over here. Okay, so far so good. And then we're going to see exactly how we might forget about the result in the last iteration. What about the fourth iteration over here? So I is 3. So that means we're looking at 5. So 5 larger than 0 is going to be true. So far so good. We haven't really forgotten about it. So true is reassigned to some positive. Okay, it's simply just going to be true over here. Now, here comes the critical points. In the last iteration, where I is simply equal to 4, so we are looking at -1. -1 larger than 0 is just going to be false. And we're going to reassign. There's no accumulation. So we simply reassign false to some positive. So now we're going to reassign that to false. And this is the final result. So the actual result, so what do we expect to see? What we expected to see for this particular array, because we know there's at least one element over here that's positive conceptually, right? So expected should be true. But what's the actual result? As we just computed, the actual result from the last iteration is simply false. So you can see that this one does not match the expected result, right? Okay? You can see the second example here doesn't work, but the first example works simply because, let me recap, which we did already from the previous illustration. Okay, now in the first example over here, the last element over here is simply 9. That is going to make sure the last reassignments for some positive will just be true. We're just lucky. Okay, that's why we got true over here. On the other hand, if you actually get the second version over there, the last element is actually -1 over here, and -1 is going to make the last comparison in the last iteration being false. So that means we're going to get the actual result being false. Okay, so you can see that for for example number 1, where the last result, where the last element over here happens to get you the correct result, but in the second example, the last element will actually give you the reverse result, which is not correct, right? So that explains why taking out the accumulation from the code is going to make your program very weird. Sometimes it works, and sometimes it doesn't work. It depends on what the last element is in the array. So now I really want you to understand exactly why for version number 2, for both problems over here, they simply don't work always. Not only that, you have to understand why they don't actually work, you also have to understand exactly under what circumstance they're going to work or not work. Okay, it's really important. It really depends on what the last element is, which is intuitively not correct. To really see if all the numbers are positive, you should really look at all the entire array rather than just the last elements. Okay, so now review this very carefully, and then before you go to the next video.